All right. Yesterday we got about to the end here. So just recapping again, let's start with that. Find the acceleration of the particle when time equals 4. Remember, there's kind of two different ways that they're going to ask you to do that. At any given time or at a specific time. Either way, I would start by finding my just generic derivative. And then if it said at any given time, I would stop there. That was like this one. At any moment of time, we would stop at our generic derivative. But if they give us a specific moment of time, then we would plug it in after we found our derivative. They give us the position function in this one. So the first step was actually moving to our velocity, which is the derivative of our position function, right? So step number 1 would be to find our velocity. You may notice just notation-wise that I indicate each time that we start a problem what my letters are standing for. So they gave us S of t. And instead of then just all of a sudden this random V of t appearing on my page and not knowing exactly what V of t is supposed to represent, is that I always indicate that it's the derivative. And now I can talk about V of t for whatever purposes, and they know what it is. It's a common notation that velocity would be V of t, but just to be on the safe side. So the same thing is I would indicate on this next one that I'm taking the derivative of the velocity, which is my acceleration function, and that comes from taking our derivative here, which would be 2. Now, it does say we're supposed to find this at time equals 4, so I would evaluate my acceleration function at time equals 4, but if my acceleration function is a constant, it's not going to change regardless of what time it's at, right? So we would still be looking at 2, and let's talk labels on this one. What would our label be for our acceleration on that? Meters per second, right? Acceleration, or velocity was meters per second, acceleration meters per second, or meters per second squared. Any questions so far? Okay. The next part takes a combo of a couple different functions, and we have to look at our position function and we have to look at our velocity to be able to describe the motion of our particle. So, motion of our particle, which direction is it going, where does it start, where is it at each of those points? We're going to look at a combo of our position and our velocity functions. So, then that part of that will be answered in here. At what values of t does the particle change directions? If we zoom in on our velocity function, if I find where our velocity is positive versus negative, that's going to tell me when our particle is moving right and left or forwards and backwards, right? So I would start by looking at the zeros of our velocity. Solving for when my velocity is 0. And I see that my velocity function is going to be 0 at time equals 2. And what I want to know is what's it doing on either side of that time. And so a lot of times we'll utilize a number line in here to kind of create what's like a sign chart for what, I don't really need to know exactly what the numbers are, but I need to know if they're positive or negative. Well, remember, we talked about this yesterday. I'm always going to start time problems at time equals 0. And at time equals 2, our velocity function is 0. But what is it on either side of that? And so what I can do is pick just sample numbers in there. And you guys have used sign charts in the past, I know, for different things over the years. And so I just pick a sample number in there. So something between 0 and 2 would be like 1. And all I do is I go plug it into my function here. And I don't need to know what the answer is. I just need to know if it's a positive number or a negative number. So if I were to plug 1 into this function, I'd have 2 minus 4, which is a negative number, right? So our velocity function would be negative in that interval. And then I pick a sample number on this side, something bigger than 2, like 3 or 4 or 10 or something bigger than 2. If I put that in here, 2 times 3 is 6 minus 4, that's a positive number, which means any number I were to pick in that area would be positive. Okay, well that tells us about the motion of our particle. When our velocity is negative, we know that it's moving left or backwards, and when our velocity is positive, we know it's moving right or forwards. But where is it starting and where is it when we hit that time where it's switching between our forwards and backwards? Okay, so then we are going to go to also to our position function. We want to look at our position. Where did it start? So let's start at time equals 0. Go up to our position function at the top, plug in our 0, 0 squared plus 4 times 0 plus 3. Particles starting at 3. Okay. The other place that I want to know where our particle is, where did our particle end up when it changed directions? Okay, well, it was moving left, it stops, and then it's moving right. Where is it when it stopped? So let's look at where our position is at time equals 2. Okay, so go back up to our position function, plug that in. Let's see, 2 squared is 4, minus 4 times 2 would be negative 4, plus 3, negative 1. Okay, does our answer make sense? Particle started at 3, moved left, ended up at negative 1. Does that make sense? Yeah? And now it's going to move right again for the rest of forever. Okay? So now we just got to put that into words. Describe the motion of the particle. Okay, so our particle is starting at position 3 at time equals 0. And then we're going to move left. Starts at 3 at time equals 0. Moves left. Let's see. For 0 is less than t is less than 2, it moves left. Why does it move left? Because our velocity is negative, right? That's our symbol for velocity is negative. At time equals 2, then we get all the way to negative 1. And we can answer this second question right now. What values of t does the particle change directions? At time equals 2, the particle is at negative 1 and changes directions, right? Now doesn't it change directions from going left to now moving right? So, and changes directions. The particle moves right for time greater than 2. So for everything greater than 2, our particle is going to move right for the rest of time. Questions on that? So that finishes up what we had at the end of our notes yesterday. Let's go ahead and go back to our notes for today. And the topic I want to add today is this concept of what we refer to a lot called critical points. So in this example here, it says find the maximum velocity attained on the interval from 0 to 5 by the particle whose position is given by s of t equals 2t cubed minus 12t squared plus 3, where s is in meters and t is in seconds. Well, when they ask us to identify things like maximums or minimums, we are going to examine these things that are called critical points. Maximum and minimums can only happen at certain places, and those certain places fall into this category called critical points, and those include these things. The end points of the interval that is given to you. So if we were to look at this problem, they give us an interval and they say look from 0 seconds to 5 seconds. And so critical points would include 0 and 5, any end points of an interval that they were to give us. And then it says any maxes or mins of the velocity function, and I'm going to actually clarify that more because we're actually looking for maxes and mins of our velocity function, but where do those happen? And maxes and mins are going to happen at the zeros of the derivative. And that is a generic occurrence. It doesn't ask, if they ask us for the max or the min of a position function, we would look at the zeros of the velocity. If they ask us for the max or the mins of the velocity, we would look at the zeros of the acceleration function. If they wanted the max or mins of the acceleration function, we'd have to find its derivative and look at the zeros of that. So you always are going to look at the zeros of the derivative to identify potential maxes and mins of a function on a closed interval. So if we look at this one, let's start with that second part, zeros of the derivative. We're looking for the maximums of the velocity function, which means we need to find the velocity function, and then we'll find its derivative. So let's start by just finding our velocity function. Using our power rule. Oops, 6t squared minus 24t. But again, if we're looking for critical points, I need the zeros of the derivatives, which means I need its derivative. So the next step I would do, so this is the function we are ultimately trying to find the maxes and mins of, or the maximum of. So now I'm going to move to its derivative to identify the potential places that that max could happen. So take the derivative one more time. And I want the zeros of the derivative. So my next step is, now that I know the derivative of the function, find its zeros. Finding its zeros is setting it equal to 0. Okay, solve for t. Okay, so putting all of those possibilities into a list here, our critical points will include anything that is the end of an interval. Well, the interval they give us is from 0 to 5. So 0 would be on that list, 5 would be on that list, and anything that is a 0 of the derivative. Well, we have one of those, and it is 2. Okay? And now I just have to go to the function that they're asking me to do the max or min of, in this case the maximum, velocity function. And we just check what we get when we plug those into that function. So I'm testing out 0, 5, and 2 in my velocity function. You can show it like this. You could do a table with 0, 2, and 5 in there and the values on the other side. It's all the same thing. It's how you prefer to show your work here. But I'm showing that I'm trying this out in my velocity function. So here's our velocity function. I'm going to plug 0 into it. 0 plus 0, 0. Okay, I'll let you guys grab a calculator and figure out the other two. Okay, what is the value of our velocity function when time is 2? What do we get? Feel free to use those nice fancy calculators you guys all have, or your brains, or wait for someone else to do it. Okay. If I were to call your name, would you be able to tell me at time equals 5? 30, yes. You guys aren't getting the hint. Get your calculators out and do some math. Okay? I'm not going to do this for you. All right. Now, your answer to this question is not that list of numbers. Your answer to this question is which one is the maximum velocity, and that is just which one gave us the biggest number. And be careful about the way it's asked. It says find the maximum velocity, and there. So the question is my answer 5 seconds or is my answer 30? Well, 5 seconds is not a maximum velocity, right? Velocity would be done in, what, meters per second. So our answer actually is 30. What is the maximum velocity? The max velocity is 30 meters per second, and it happened here at time equals 5. Questions on that? Just be careful that they didn't ask when did the maximum happen, that we're answering the correct question at the end there. Okay. All right. The next two are ones that we have kind of seen before. So I'm going to let you guys try these a few seconds before I get started on them, see if you can remember how to attack a problem like this given this information. It says, a hot dog is shot upward at a Husker football game, and its position in meters is modeled by y equals 8t minus t squared. Find the following. First question, the maximum height and when it happens. Second question, the velocity and speed of the hot dog when it is 7 meters high on the way up. Okay, with that being said, we don't have a ton of time left. So let me go ahead and talk about these. Again, ones we've seen before, but remember maximum height is talking position, and anytime we want the max of a function, we need to look at the zeros of its derivative. So I would start by finding the derivative, finding its zeros. Okay, so that actually answers the second question. When did that occur? Time is in, it doesn't say, we're going to go with seconds. Time is in seconds. And so the second question, when does it happen? 4 seconds. What is the maximum height? Goes back to our position function. Plug in 4. Let's see, 32 minus 16. 16 meters. Okay. Second part, the velocity and speed of the hot dog when it is 7 meters high on the way up. To figure out when that happens, remember this hot dog is being shot up into the air. It reaches a height of 16 meters, and we want to know when it is 7 meters high on the way up. I need to know when that happens. Well, in order to know when that happens, we need to find out that from our position function. When is our position equal to 7 meters? So I would set my position function equal to 7 meters. Solve, we get 2 t values, either at time equals 7 seconds or time equals 1 second. Well, the one that's going to be on the way up would be at time equals 1. So what is the velocity and speed? We go to our velocity function. We evaluate at time equals 1. So we would get 6 meters per second. Because that's a positive number, that would also be our answer for speed, right? Also 6 meters per second. Questions on that? Okay. On the last one, same situation. When is the velocity of the hot dog positive? When is the velocity of the hot dog positive? We've already done some of the legwork for this one, haven't we? We've found our velocity function. We found the zeros of our velocity function happen at 4, right? So if we use that velocity function, we look at starting at time equals 0. It is 0 at time equals 4. All I want to do is look at, okay, where is it positive, where is it negative? We can use a sign chart. Pick a number that's between 0 and 4, like 2. If I plug a 2 into this function, this is a positive number, right? If I plug something bigger than 4, like 10 into here, this is a negative. Where is our velocity positive? From time equals 0 to time equals 4. Last one, when is the acceleration of the hot dog negative? That means we need to figure out our acceleration function, right? So we would have one more step, take your velocity function, find the second derivative of our position function or the derivative of our velocity function, and we get that it equals -2. So when is it negative? Always, right? It's just a negative number. So it's never going to change. It's always negative. So we would say for all time, as time is greater than 0, it's a negative number. It's a negative acceleration. Any questions on that? Okay. Tomorrow, similar, we'll just talk through, again, a lot of the questions that you guys are going to get on your worksheet and try to continue to see the different ways that these things can be talked about and asked, etc.